Hi everyone, I'm meteorologist Royal Norman. Welcome to Sonoran Sky Live. Did you hear this over the weekend from the Boston area? Yeah, sonic booms and dogs running and everybody calling 911, and it was what the heck is going on? It turns out, well, I'm probably gonna get this wrong, but it was a pretty big meteor or meteorite. Well, that's why we have Carson Foles in. He's director of the Catalina Sky Survey. Oddly enough, Carson, as you know, we scheduled this a couple of weeks ago, and then this week in a little serendipity, we got this thing happening back in the metro Boston area, which, you know, it's surprising to a lot of folks, and I believe there wasn't many folks that actually saw anything because it was a cloudy day. But tell us what happened this past weekend in the Boston area.
Yeah, so this past weekend there was a bolide event near Boston, and what that was a fairly small asteroid, came and impacted Earth's atmosphere, kind of out in the ocean there. This particular object was fairly small, about 5 feet in diameter, but it's made of solid rock, so it's pretty heavy. It was a couple of tons. It also came in at a very steep angle, so kind of straight down into the atmosphere, and that sonic boom everyone heard was it creating that pressure wave in front of it and exploding in our atmosphere. This wasn't a threat to anyone. Like I said, it was over the ocean, and the weather radar in the area did pick this up and actually showed that there were a couple of small kilogram-sized fragments that rained down, but they rained down into the ocean. But yeah, I'm sure it was really startling for people in the area. This came in without any notice.
Well, and that's the question. The Catalina Sky Survey, well, first of all, let's back up. That was interesting this weekend. I want to find out what the Sky Survey does. And is that the size object you're looking for, or is that just too small?
We do pick up imminent impactors of that size from time to time, and when we do, they're always a great practice run for our endeavor, planetary defense. But our mandate from Congress is to look for much larger objects, 140 meters in diameter and larger. Those are what we're really after in the focus of our work.
So, yeah, so it might just be happenstance you would pick up something that size. Now, about a month or so ago, and this is why I sort of reacquainted myself with you all, the Catalina Sky Survey, you found a near-Earth object. Before we ask about what a near-Earth object is and all that, let me know about the Catalina Sky Survey, because you're really one of the big organizations that's trying to look for these things up in space, are you not?
That's right. We're one of the most prolific discoverers and trackers of near-Earth objects in the world. So we are a NASA-funded project here at the University of Arizona. We run out of the Lunar and Planetary Lab, and we use telescopes from Stewart Observatory, our department across the street, to scan the skies every single night that we possibly can, and try to discover and track near-Earth objects.
Now, how is that done? Is that, here's the only way I can imagine it. You're taking a time-lapse shot of part of the sky, and you're trying to see if something moves through it. Am I oversimplifying that, or what?
No, I mean, you got it exactly. Trying to find new objects, we do take a series of images with our wide field of view cameras of the same spot in the sky, separated by a couple of minutes, 8 to 10 minutes. We take 4 images of that same spot in the sky, and then we can tell that things in those images are moving. The stars in the background are kind of always in the same spot. They don't tend to move, but the asteroids, they change position between those images. And if you animate those just like you would a cartoon that you drew, you can kind of see their motion across the sky. And we have lots of software that works really hard to pick those out of our images. Not only that, but we actually have people physically at the telescope running the survey, making decisions of where to search, and they actually review that data as the final confirmation for discovering these objects.
Now,
And
I
once
know,
we discover the,
sorry about
oh,
that.
sorry,
I interrupted. Keep going.
So once we discover them, then we also need to track them for a while,
Mm-hmm.
so we can understand their orbit. Discovery is about a 30-minute process. tracking to make sure that there's no impact risk to Earth takes a couple of days.
Oh, okay. What I was going to ask, though, is that when you are tracking these things, you use the term asteroids. I use the term meteor. All right, tell me, you're looking for asteroids then? But is an asteroid to you any rock or mass that's moving around out there that we can't see real readily?
That's right. So I like to say, when it becomes a meteor or a meteorite, that's past us having anything to do with it. So objects in space are asteroids and also comets. We track both of those. So when they're in space, they're asteroids. As they are coming through the atmosphere, think of the shooting star phase. That's a meteor up there.
Uh-huh.
And when they are on the ground in your hand, that is a meteorite. But they are all the same, object.
They're all the
different
same
names for where it is.
Now, we have a chart, which I think you'll be able to see too, but you're quite familiar with it. And it just shows that we get hit a whole lot by sand-sized grains or less of meteors every day practically. But as the size increases, the possibility of a hit on Earth decreases tremendously. So these are just statistics, and I mean, here in Arizona we like to talk about, well, 100-year rain, and then the last 10 years we've had 10 100-year rains. So it's just statistics, but it does show that it's unlikely. But why do you think that when people hear about an incoming asteroid or whatever, there is I don't know, a tension, let's say, or that kind of emanates? Is it because we think we've had asteroid events that have, led to extinctions on the planet in the prehistory of our planet?
Sure. I mean, that's probably a big part of it. Everyone's familiar now with the story of the dinosaurs and that an asteroid impact wiped them out. So it's on people's mind. I think also the fact that we're doing a better job tracking and discovering these objects means that you get more information about ones that are coming close as a byproduct of finding more of them.
So when you found the one in May, and I had to write this down, it's called 2026, it was called. It probably still is, 2026 JH2. When you discovered it, the internet went crazy, and, people are trying to get clicks, so we all get that, right? But you just said that it takes a couple of days to actually figure out the track. So when did you discover it? And how long was it after that you all pretty much felt this was not an Earth threat?
So I just looked this up. We discovered it on the evening of May 9th, and it had its closest approach to Earth about 8 days later,
Okay.
May 18th.
Okay.
We could tell pretty quickly that this object was going to come close. But our orbit solutions were good enough within a day or so to say, okay, it's going to come close, but not impact the Earth.
Yeah.
After that, it was just figuring out, exactly where it's going to go. But the impact probability was ruled out quickly.
Yeah, I really have to stop interrupting you. But I'm so excited about it because, the one thing I was reading at that point was that there were a lot of internet whatever, tweets and all that kind of stuff, which said, this is coming so close, it's going to pass within most of the satellites on Earth. And I was like, no, that doesn't even ring true in my mind, and I don't know anything about astronomy. It was close in astronomical terms, but it really wasn't close in terms of close terms, right?
That's right. So it was exactly what you said, close in astronomical terms. It came closer than the moon.
Yeah.
But it was still 55,000 miles away. That's further than most satellites. There are some that go on extreme distances, but most satellites are closer to Earth than this object was.
Yeah, I believe I recall that most of our geostationary satellites are around 23,000 miles up or something like that. My old textbook learning coming back there. So the bottom line is, though, it really is easy to get folks, because rightly so, everyone heard this big boom in the Boston area, and then rightly so, there's an asteroid coming to Earth and it's kind of close, and that's all we hear, so it's kind of understandable, isn't it?
Yeah, it absolutely is. I'm glad people are more aware of just how crowded and dynamic our solar system is. That's fantastic. But we have had objects that have had non-zero impact probabilities, and when that happens, there's an entire worldwide community that kicks into gear to track and characterize these objects.
Yeah, it's a really interesting field. Now, I want you to categorize this. You said it was about 8 days, discovered 8 days before it made the pass by. It's not a flyby. It ain't flying. It just came by. So, in your terms, was that late, early, about average? Tell us.
So the trick with discovering these objects is the smaller the object, the dimmer it's going to appear in the sky.
Okay.
And so we just can't see them until they're much closer. That kind of works to our advantage. The larger objects, the really dangerous ones, we can see much further out, and hence, if they are on an impact trajectory this orbit, we have longer to do something about it. In which case, it would probably be like analogous to a hurricane. FEMA starts evacuating people.
Right.
And we have those fans in place. But our goal really is to discover these large 140-meter and larger objects with years of time to mount an actual space mission to deflect these.
And how big was JH2? Oh no, you said about 5 feet. Is that right, or was it bigger than 5 feet?
So the bolide in Boston was about 5 feet.
That's right. Yeah.
JH2 was anywhere from 50 to 100 feet. So that would have been a significant event if it had impacted.
Okay.
But not world-ending.
We'll tell you how significant, and we'll show you how significant after we take a little bit of a break. We're talking with Carson Foles, the director of the Catalina Sky Survey. We'll be back in just a couple of minutes. Welcome back to Sonoran Sky Live. We're talking with Carson Foles, the Catalina Sky Survey director, and we're talking about near-Earth objects floating around out there, which is a really fascinating topic. Now, Carson, just to sort of refresh before the break, the last nearest flyby in May, you were estimating that object is what, 100 feet or 50 to 100 feet in size, diameter?
Right. Mm-hmm.
So I want to show you a picture of one of my favorite landmarks in Arizona, and I believe I've got this correct. That's Meteor Crater. You're familiar with it.
Yes.
I believe that was about a 100, they estimate a 150-foot diameter, maybe larger, asteroid back in the day. So as you say, even an asteroid of that size is going to do some damage.
That's right. We kind of refer to those as devastating for a city-size region.
Ah, so this could be the type of thing sort of like you used the term hurricane, but more of a regional impact. And you know, when you think about it, you see these cones and whatever, but you have to think of all the upwelling of dust and stuff like that, and you have to think of power outages, and so there's a million things that happen if one of these would happen if one of these got close. In fact, didn't we have one that struck in Russia within the last decade or so, and it was widely seen on a bunch of auto cams and stuff, and it made huge booms up there. So, I mean, these big ones do strike occasionally.
That's right. That was in Chelyabinsk in 2013, February 15th, 2013 in Russia. That was a fairly large object, still not quite as large as what caused Meteor Crater, but you know, the impact energy released from that, and it was all released in the air, was equivalent to a small size nuclear weapon.
Wow.
It's pretty amazing that that much energy is packed into these events that happen, you know, from time to time.
Yeah, and I remember, I may be remembering wrong because now you're saying it's over a decade ago, but you know, there were areas where trees were just flattened down. It was just an amazing, some of the amazing power of this thing that, as you say, exploded essentially over the land. So let's get back to what Catalina Sky Survey does. You're tracking, you're looking for the big ones, and I have a chart in front of me which I unfortunately didn't get up in time to share, but one of the things about the big ones I've seen is that since 2000 there's now been over 10,000 of these discovered, which seems like a huge amount. Is that a huge amount?
It is, you know, like I said, our solar system is a very dynamic and busy place. So we are still discovering every night new near-Earth objects. In fact, last night, even though it was really close to the full moon and you know, the sky quality wasn't great, we still discovered 2 new near-Earth objects in addition to tracking, you know, a couple of dozen others at the time. But we tend to discover worldwide as a community a couple of thousand new near-Earth objects every year, and many of those are you know, large. 140 meter and larger.
Well, the ones you discovered last night, were they 140 meters or larger? Hope not.
No, they were you know, kind of in the 50-meter range.
Okay, so 10,000 seems like a lot, but if you look at all the near-Earth asteroids discovered since about 2000, and really we didn't have a lot of we had the technology, we just weren't that interested in it, but over 40,000 have been discovered. So again, I'm thinking if that many has been discovered, there's a lot of stuff out there we haven't discovered.
There is, but the good thing about that is, you know, as we discover more and more, our technology advances, we get more telescopes on the job. The really large objects, you know, the kilometer size, our discovery rate now for those is basically flat.
Yeah.
We have discovered, I think last year, two objects larger than a kilometer, and they were all, both those objects were very distant, come not that close to Earth.
Oh, that's good.
And like I said, these larger objects are brighter and hence somewhat easier to discover. We're really focused on the large, you know, 140 meter, but really out to about 200 meter class asteroids these days. And we have we think about 50% of those have been discovered so far, and we're trying to crack that last 50%.
And you know what, you can see this on this graph, exactly what you're saying. It's just almost a constant line of discovery on the big ones, but the little ones go whoop as your technology got better and you're able to find them, those little guys, a little easier. I'm imagining that's what that graph is sort of showing.
That's exactly right.
So sometimes you guys discover, again, you guys, the scientific community discovers one of these, and initially, especially when they're far out, it takes a while to sort of get a resolution on whether this is going to be a near-Earth object to worry about or not. Is that correct?
That's right. And I can tell you why as well. Folks always wonder, like, why don't you know where these are going? We're taking images of the sky. You know, we see the asteroids and we see the stars, but they're just flat pictures. What we don't get with that piece of data is how far away are these objects, right? We can't tell from a flat image of the sky the distance to these asteroids. That's why we have to track them for a while to start seeing their orbit out in space before we can really clamp down and say, okay, this is exactly where it's going.
Yeah. So it does
Uh,
take time.
it does, and that's why, we're trying to get 3D information from a 2D image. If they come close enough that we can use radar systems to bounce radar waves off of them, then we immediately get the distance the orbit is known really precisely at that point. But just using telescopes and light, we're subject to the laws of physics.
Yeah, that's for sure. And I have noticed in the past that some of these have been discovered. Initially, I don't know that they're termed a threat, but they're like, okay, this is an asteroid watch, if you will. Let's keep an eye on this. Sometimes we in the community get a little excited about that, okay, 4 or 5 years down the line. But then you continue to resolve that. It's not we're one and done on the resolution. You continue to resolve this, don't you?
That's right, and we do have something analogous to severe weather watches and warnings. The International Asteroid Warning Network, IWAN, is the group that is tasked with ingesting all these observations and orbits of these objects, and then if there is an object that has some impact probability, they've set thresholds for actually threatening objects, then it is their job to notify the United Nations and distribute that to the members states to let them know, hey, this is what's going on. It's really equivalent to a severe weather watch.
All right, Carson, this is great stuff. Oh, we've got to take one more break before we get back. Carson Foles from the Catalina Sky Survey. We will be right back. Welcome back to Sonoran Sky Live. I'm meteorologist Royal Norton. We're with Carson Foles. He's from the Catalina Sky Survey, and we're talking about near-Earth objects. Man, I got so much to ask you about, but I'm going to start with this. In the movies, there's been a bunch of blockbusters where somebody goes up and tries to blow up an asteroid. We're not going to try to do that anymore. We figured out a better way if we can get it done. That's what I've been reading anyway.
That is absolutely correct. We have the means now, and those means have been tested to actually deflect threatening objects in the event one is on an impact trajectory. With recent space missions, we've actually been able to send a probe, impact an asteroid, and change its orbit in a meaningful way. and that's already been tested, deployed. We can do it again if we have to.
And I figure, knowing a little bit about physics, the farther out you find that, the smaller you got to move it to get it to miss Earth or, you know, not even come close.
That's absolutely correct, and that's why when we discover these objects and track them, we like to compute, you know, for the next 100 years, is there any chance that this object will impact Earth? Because that's the kind of lead time that we like to have.
Yeah, for sure. So you mentioned early when we were talking earlier on the show that there are plans in place not only to detect, but you said we will rehearse planetary responses. We'll use some of these things to rehearse planetary responses. What is that? I mean, I never thought there were folks responding to that kind of thing.
There actually are across the world. So I1 is one component of that. You know, the group of experts to advise the governments of the world. We also run kind of tabletop exercises every 2 years or so of, you know, running through what would happen if we found an object on an impact trajectory. You know, who would we need to call? What type of evacuations would we need to set up? We also coordinate with the space agencies all around the world. So the group that's responsible for that is called Same Page, and they are responsible for recruiting all countries with the space program to work together to develop these mitigation missions.
Yeah, I was getting into that a little bit a few weeks ago when I first of all went to your website and then started going to some, you know, other websites, and it's fascinating. One thing I noticed, at least with some of the organizations, that there's a fair amount of volunteer work being done. Is that the same with Catalina?
So everyone at Catalina is all 17 of us are full-time working on planetary defense and discovering these objects and tracking them. However, you know, we produce so much data,
right?
And our observers at the telescopes can only review so much in a night, even though they look through thousands of potential candidates. There's still many more that we produce in our data that are kind of lower probability of being actual objects, but it's still good to check them. So we have developed a citizen science project hosted on the Zooniverse platform. Our project is called the Daily Minor Planet, where we take data from basically last night at our survey telescopes and upload that for anyone around the world to review and let us know, hey, is there an asteroid in this image? Do you see an asteroid or do you not? And that project has been incredibly successful, discovered thousands of main belt asteroids, and about half a dozen near-Earth objects were discovered by that program. In fact, just last week, their newest discovery was 2026 KS3, about a 100-meter diameter object that was discovered just by the volunteers on that project.
Wow, I mean, that's pretty amazing. So I don't know that I could do it, but somebody could get online and sort of help you guys out and say, hey, I think I might see something here, and then you could review it.
Absolutely, that's exactly how it works, and you can do it with, you know, your laptop, your tablet, your phone. I like to tell people, like, stop doom scrolling and really do some doom scrolling. Help us out.
That's really a good point. Although you did say something about, you know, planetary defense, and man, that just hit me like a brick, because again, something that we don't think about every day is people like you that are thinking about planetary defense. Wow.
That's it. You know, there is a small but highly dedicated group of individuals all around the world who take this seriously. I love astronomy. I love, you know, thinking about stars and black holes and galaxies, but this is the part of astronomy that really connects to people and life on our planet very directly. We saw what happened to the dinosaurs, and we have the technology to potentially prevent that from happening to us.
Yeah, I like that. It's science in the real world. I love astronomy too, and I love all the theories and the string theories and all that. But this is real, and this is something you're doing today. And Carson Foles from the Catalina Sky Survey, we appreciate you and all the other organizations that are doing that, who are defending the planet while we're just watching the weather and the clouds float by. Carson, it was a pleasure talking to you. I hope we get to do it again sometime.
Absolutely. Thank you so much for having me.
Yeah, take care. Have a good day, everyone.